mathematicians. In this video, you're going to learn about function notation. Now, because the relationship between the input and the output is so important for functions, we use a special notation. Let's start by looking at an equation for a linear function. Y is equal to 3x minus 2. Now, this notation for a linear function should feel really familiar. By looking at this, we know the input is x, the output is y, and we could say y is dependent on x, or we could say y is a function of x. And we talked about those in the last video about the relationship between age and height. Okay, are you ready? I'm going to now show you what function notation is going to look like. Now take a deep breath. It's going to feel really funky to start with, but you're going to get used to it. All right, so the function notation is, and we say this, f of x is equal to 3x minus 2. So this little piece we say is f of x. Now it's super important. These parentheses have nothing to do with multiplication. F is not a variable. We're going to talk about what each of these pieces are, but I can't stress this enough. These parentheses have nothing to do with multiplication. All right, so let's go through the different pieces of what each thing means. We're going to start with the x. And the x just represents what the input is. So very similar to what it was before. The f. This is not a variable. This tells us the name of the function. So this is the name of the function. The name is always a single letter. It can be uppercase, it can be lowercase. We tend to use, for just generic functions, f, because of f is for function. Other really popular ones are lowercase g, lowercase h, you'll see, but really any lowercase or uppercase letter is fine for the name of your function. All right, next up, this whole thing, and this whole thing, we again say f of x. This whole thing represents the output. And we're going to talk a lot more about this because it's hard to imagine this packet as meaning a single value, the output. And when we look at some examples, we'll talk more specifically about that. And then finally, the last piece, 3x minus 2, we call that the function rule. It's really defining the function. It's what do you do to the input to get the output. So we could call that the function rule, and it defines the function. All right, so those are our different pieces. I'm going to draw a quick little function machine just so we can see a visual for this. I just draw my function machines like this. All right, so we have our input into the function machine, and that's our x. The input comes in, and this function machine, the whole thing, we're going to call it, this is our function machine f, our function f. We come in, and the rule tells us to multiply by 3 and subtract 2, and then what comes out will be our output. And we again call that output f of x, and that's going to be our output. Let's look at one example to start pulling all these pieces together. And we're going to use the same example that we introduced before, where we say f of x is equal to 3x minus 2. Let's say now we want to know what happens when we input 3. So this is saying f of 3. What's the output when we input 3? So we're going to replace the variable with the input. So let's be really clear. These two values That's the input. All right, let's do our arithmetic. 3 times 3 is 9. Oh, that should be a minus. 3 times 3 is 9, minus 2. So this is equal to 7. So when we put it all together, whoops. Okay, let's go. F of 3 is equal to 7. Excuse me there. This is such an important notation because it tells us, first of all, the input is 3. The output is 7. And this piece is saying when we input 3, the output is 7. Let's just do one more quick one. Let's say we input -2. Then we're going to take 3, multiply it by -2, and subtract 2. And that's going to be -6 minus 2, or -8. So when we input 2, the output is -8. This is going to feel a little odd for a while, but it's so important because it clearly shows us the input and the output. And again, this whole piece, f of -2, says what is the output when the input is -2? That output is -8. All right, take a deep breath. Function notation is super important, and after you work with it for a while, it's going to feel very natural. Okay, let's do a little practice.